This is a question from a previous ZAT paper where uh, this is from probably a time where all the binomial expansions etc. were very popular. Very unlikely to come up in CAT or ZAT at the current stage. It's from 2011 ZAT, but still, let's see how to solve it. It's more likely to be solved using conjugates and indices. Also, let's see how we can solve this. If x is given as this 9 plus 4 times square root 5 to the power 48, and this is the square bracket x plus f, where square bracket x, which is your greatest integer function, is the integer part of x and f is a fraction, then x into 1 minus f equals how much? Okay, so if it says it was 45.3, then the greatest integer will be 45 and fraction will be 0.3, right? So this is how it works. Now let's see, if you observe this carefully, the entire trick in solving this question is the value. Okay, 9 plus 4 root 5. 4 root 5 is root 80 and this is root 81, right? So 81 minus 80 is 1. So let's look at the conjugate of this. So if we take 9 plus 4 root 5, okay, so if I take y as 9 minus 4 root 5 to the power 48. Now you know x into y will give you 1, because it will be 9 square minus 4 root 5 whole square, that will be 1. 1 to the power 48 will give you 1. So this gives you the conjugate into the original number gives you 1. Okay, now let's see how to expand this. We also observe that this value is less than 1, right? Root 81 minus root 80 will be less than 1, right? So even to the 48th power, the value will be getting even and even smaller. So y is less than 1. We also know y is less than 1. Now, can we get a relationship between x, f and y? Let's see if we can do this. Okay, now if we expand x using binomial expansion, you will get 9 to the power 48 plus 48c1 into 9 to the power 47 into 4 root 5 to the power 1 plus 48c2 into 9 to the power 46 into 4 root 5 to the power 2. It will keep on continuing till the last term will be 4 root 5 to the power 48. Similarly, if I do it for y, y will have this term, then you'll have negative this term, then you have positive this term, keeping on going till the last term will be the same. Now, if you observe this, all the odd, wherever the power of 9 is odd, the power of 4 to the power 5 is also odd. This gives you an irrational number. All these numbers are irrational numbers. Whereas wherever it's an even number, this is 4 root 5 square. So root 80 square will be a rational number. Similarly, 4 root 5 to the power 4 will be root 80 square to the whole square. That will also be a rational number, and so on. So if I add x plus y, it should give you a rational number, because the negative terms will cancel out. Only the positive, and the positive terms will get doubled. So x plus y will give you twice, everything is this, twice of a rational number. Also, this is a natural number. So twice into a natural number, right, which is an even number. So x plus y has to be a even number. We also know y is less than 1, and by definition x is the integer part of x plus the fraction, which means the integer part of x plus fraction plus y is a even number, right? We know x is a natural, the integer part of x has to be a natural number, right? Integer part of x has to be a natural number, which means f plus y also has to be a natural number. That's the only way. That's the only way you will balance this. A natural number plus another natural number will give you a even number or any natural number. A natural number plus a fraction will give you a fraction, right? We are guaranteed that this is a natural number, right? Which means f plus y should also be a natural number. Now, we know the fractional part will always be less than 1. 45.8, if you take 45.8, 0.8 is less than 1, right? That's the reason why it's a fractional part. Similarly, y is guaranteed to be less than 1, which means f plus y should be less than 2. F plus y should be less than 2, right? Now, f plus y is a natural number and it has to be less than 2. How can you get a natural number? The only natural number which is less than 2 is 1. Which means y equals 1 minus f. That's the only way out. If f plus y equals 1, y should be equal to 1 minus f. Right. What do we need? We need x into 1 minus f, which is same as x into y. And we already started this entire premise. We knew that once we multiply it with its conjugate, you get 1. Right, so xy is equal to 1, which is what you need. It is exactly equal to 1, not less, not between, more than 2. It is exactly equal to 1. That finishes this question. It's a slightly lengthy question to explain, but it's not difficult to do. But in an exam situation, most people would leave it, right? Key point is conjugates and the binomial expansion. That finishes this question.